Welcome everyone. Thank you for joining the Kubeadm deep dive today. We're going to do an introduction of what Kubeadm is. We'll also look at what is the current state of Kubeadm and what is the future for it. So for that, here's Ross with me. So we're going to make an introduction. Please, Ross, go ahead.
Thank you, Rafael. I am Rostislav, or simply Georgiev. I work at VMware's Open Source Technology Center as an open source engineer.
Hello, I'm Rafael. I work for SUSE and I'm a Kubeadm contributor. So let's get into the contents of the presentation. So what is Kubeadm? Kubeadm is a Kubernetes node bootstrapper. It's basically a tool to get a minimum viable secure cluster running in a user-friendly way. It's important to note that we have some requirements before you can bootstrap your cluster. So in this case, someone or something has to provide you a machine or a set of machines where you are going to run Kubeadm. A container runtime and a kubelet must be already installed. The container runtime can be CRI-O, can be containerd, can be Docker, any of those will work. Kubeadm will not install any CNI for you, any CNI plugin. So you have to choose which CNI plugin you want to use and install that after Kubeadm has bootstrapped your cluster. On our end-to-end tests, we are using Calico, but you can use any CNI that is supported by Kubernetes or that integrates with Kubernetes just fine. So it's also agnostic regarding a number of things. So as we said before, regarding CNI, regarding container runtime, but also it's agnostic regarding cloud provider and machine type. So Kubeadm is designed to be easy to use. It's thought in order to provide same defaults for the majority of use cases that you might have. But also if that doesn't fit the bill, then the idea is to make the other part possible. So this is the Kubeadm is part of the SIG Cluster Lifecycle project or the SIG. So the objective of the SIG is to simplify creation, configuration, upgrade, downgrade, and tear down of Kubernetes clusters and their components. So Kubeadm is like the glue between the user and the number of components that Kubernetes has. In this case, we can see here the diagram. We have a number of components, a number of projects. For example, etcd-adm allows you to create a number of etcd instances, a number of etcd clusters, along the lines of how Kubeadm allows you to create a Kubernetes cluster. Then we have also the cluster add-ons project on the SIG. Also cluster API that we will see that in a second uses Kubeadm or can use Kubeadm. We have other projects, like for example, the component config that goes across different SIGs and across different projects. And also Kubernetes cluster provisioners that can use cluster API in order to define and create declarative clusters in a declarative way. So who uses Kubeadm? Until now, or until very recently, or relatively recently, it was we have a very good base of users, human people who actually goes and runs Kubeadm or uses some tooling to run Kubeadm. But from some time, many projects have started to use Kubeadm as well and to actually use that inside their project. So for example, we have Minikube, we have Kind, or we have Cluster API. For example, Cluster API has the concept of bootstrap provider, and the bootstrap provider, for example, for Kubeadm allows you to use Cluster API that will use Kubeadm bootstrapper to actually initialize your clusters. So how does Kubeadm work? We have different ways of setting your cluster. One is the single control plane scheme, and the other is the HA. So for the single control plane, basically your worker nodes will point directly to the control plane node. So this is a very simple schema, probably for some kind of CI or something that you want to test, for example, in a really fast way. And then we have the HA setup. So for the HA setup, we have the worker nodes that will talk to the load balancer, will reach directly to the load balancer that will in turn load balance all your API servers, all your control planes. So Kubeadm will take care of managing the control planes or of configuring the control planes, upgrading them, but Kubeadm will never manage your load balancer. So we have documentation on how to set up the load balancer, but Kubeadm is not going to manage the load balancer for you. So you have to manage that in the best way that you are doing right now. So what is the main workflow of Kubeadm? So the main workflow is to set up a new cluster. So for that, we have to go to the first machine that we want to make a control plane node and run Kubeadm in it. After that is done, we already have an API server, controller manager, scheduler, and other components running on top of the cluster. And we want to deploy a pod network add-on, a CNI plugin. So for that, we can choose the CNI plugin that we prefer. As I said before, you can use Calico, for example, that is running in our end-to-end testing. And after that is running and you have the CNI plugin ready, you can join more control plane nodes. So for that, you only have to run the kubeadm join command. Everything is documented. Our documentation is pretty extensive, so you only have to have a look at that. But in this case, you just say where the control plane host is, where is the control plane port, where is the token, the joining token, the bootstrap token, the discovery token CI-cert has. So you know that you are reaching the API server that you expect. There is no man in the middle happening. You say that this is a control plane, and then you pass on the certificate key. So the certificate key is for decrypting some secrets that were upgraded on the Kubeadm init, some certificates that were auto-generated and uploaded to the cluster after it was initialized. And so if you join more control planes, you want an HCI setup, you want these secrets to be decrypted, and the certificate key is how it's decrypted. So after you have joined these optional secondary control planes, you can go ahead and join worker nodes. These worker nodes will actually run your workloads. So for that, it's very similar to the previous step, but it's even more simple because you only have to run kubeadm join, point it to the control plane host, control plane port. If you have an HCI setup, this will be typically your load balancer that is in front of all your API servers, but this can be, it depends on your setup. So you again use the token, the bootstrap token. So the kubelet in this worker node will be able to join the Kubernetes cluster and register itself. And then again, the discovery token CI-cert has. So it again knows where it's reaching to, and it can validate that. But Kubeadm is not only for bootstrapping. Kubeadm can also upgrade your cluster. So where is the upgrade workflow of Kubeadm? You can check what upgrades are there available for your clusters. So Kubeadm will check which running version of Kubernetes you have. This is stored in a configuration that we'll see in a second. But basically, you can just ask Kubeadm, I have this version of Kubernetes, please detect which version of Kubernetes I have, and please check if there are new versions available released. So Kubeadm upgrade plan will tell you not only the Kubernetes versions, but also other add-ons, like for example, core DNS or other add-ons. And then you can actually upgrade your cluster if you want to. So you only have to run Kubeadm upgrade apply on your first control plane node. It doesn't need to be the control plane where you bootstrapped. The first node is just one of the first of the control planes that you want, but you run Kubeadm upgrade apply only once on this very first control plane that you want. And then you go with the rest of the control planes, the secondary control planes, if you have any. If you don't have an HCI setup, then you only go directly with the workers. And then you run Kubeadm upgrade node on all of them, secondary control planes and worker nodes. And this will basically read the configuration and see what needs to move to. So let's see what is deployed when we deploy a control plane with Kubeadm. So you can see the blue boxes, which are Kubernetes components. The part where we are talking about the control plane, it's basically kube controller manager, kube scheduler, kube API server, and kube proxy. You can mix and match and remove some of these components, but this is the default setup. So we are going to focus on this one. So it will also deploy core DNS as an add-on. Also, we have etcd, which is something that we also deploy as a static manifest, the same as the rest of the control plane. But yeah, etcd is only running on the control plane nodes. You need to have, you need for control planes to talk to each other in order for etcd to be able to work properly. And then you have the CNI plugin pod that you deployed on top of it. This will typically run across all your nodes, control plane and worker nodes. And then on your worker nodes, you only have the CNI plugin pod that we said before, kube proxy, from Kubeadm, and then your regular workload. So that is basically it, and that is what is deployed. And we try to make it minimal, so it's really easy for you. So we were talking before about the config. So when we upgrade, we read the configuration that we are running actually right now of Kubernetes. So we know if there is a new version available, where is this placed. So this is a configuration map living on the namespace kube system. It's called Kubeadm config. And this contains the cluster configuration and the cluster status objects that basically Kubeadm uses and upgrades or touches or updates in order to know what is the current state of your cluster, and also to compare that to a future state, for example, if you're trying to upgrade or if you're trying to do something else. So Kubeadm will basically download this config map when you do some operations like join, for example, or upgrade. This Kubeadm config map will be downloaded, will be compared, and will be probably updated depending on what you did ask Kubeadm. So what is the current state of the project? So right now, Kubeadm is stable and is GA. It supports 8C environments. We are also testing this on our CI. Our configuration is right now at V1 Beta 2 version. We are in discussions to introduce a V1 Beta 3, but we are really conservative on the changes that we make to the configuration. It has dual stack support. You can also customize your static pods. So Kubeadm will write the static pods that Kubelet brings them up. So for these components that we were talking before, etcd and Kubernetes components, control plane components, you could use customize before in order to customize these static pods, but this changed. Ross will talk about that in a second. Kubeadm also has certificate management, so it can create certificates, it can reuse your certificates if you provide them. It will also renew them if it can, if it has the CA and the key for the CA. So Kubeadm will in general take care of all this for you. Kubeadm has a managed etcd mode, the default one. We call this the stacked etcd. You can also use external etcd if you want by providing this into the configuration. But by default, Kubeadm will just manage this for you, so you don't have to worry about that, even on 8A environments. Then we are deploying standard add-ons, core DNS and kubeproxy. So you can opt out of them, but by default they are provided. And then we have phases support. So on the workflow that we were seeing before, all these phases will be run one after the other, but you can, instead of running the whole workflow, just run the parts that you care about, the part that you want to run. So this is the phases support. And right now, Kubeadm init, join, reset, and upgrade node supports phases. More commands will introduce this in the future. And with that, I will leave that to Russ. So yeah, thank you for listening.
In the 1.19 release, we're introducing patches. This is a replacement for the old customized support that we introduced about a year ago, but we have already deprecated it. So these patches are the good old well-known kubectl patches, and these are strategic JSON and merge patches. They're much more lighter and simpler to use than the old customized patches, but they're basically used in the same way as customized patches to patch static pods on a per node basis, as we are actually trying to deploy a control plane node. These patches are specified to Kubeadm using a specific directory full of different patches. Every patch is placed in its own file, and the files are named in a specific convention, which you can see on the screen, but I'm not going to cover in great detail there. These, for example, you can see a couple of patches here in action. The first patch on the top left is a strategic patch in a YAML format that's going to be applied against the kube controller manager pod, and it's going to introduce a new annotation called the extra annotation with a value of hello to the static pod of the kube controller manager. The second patch here, the one on the right, is being applied against the etcd static pod, and it's using the merge strategy and in JSON format. These patches are all specified by placing them in a single directory, and the path to that directory is supplied as an argument to the --experimental patches command line option. And this option is right now supported by kubeadm init, kubeadm join, kubeadm upgrade apply, and kubeadm upgrade node commands. Another thing that we are actually preparing for you in 1.19 is some component config updates. Now, most of the component config updates are actually happening under the hood, but in 1.19 you can see that we have actually introduced a new component config state table that's going to be printed out at the end of the kubeadm upgrade plan command. This state table actually shows you the different component config API groups, the current version, and the preferred versions of these configs. It also shows you whether actually a manual upgrade is required of any of these configs. Now, what lays ahead for kubeadm? The first and probably the biggest change that lays ahead for kubeadm is moving kubeadm's source code from the main Kubernetes repository, which is right now at github.com/kubernetes/kubernetes, into the kubeadm specific GitHub repository, which is going to be github.com/kubernetes/kubeadm. Now, this is effort is actually put on a pause right now, simply because it requires a lot of different changes to CI and release infrastructure. It also requires a little bit thinking on how versioning is going to be applied and stuff like that. So we are currently pausing on that, but this is one of the future items that we are actively looking into. Another thing that is going to be implemented at some point is machine readable output. Currently, kubeadm supports machine readable output on a couple of its commands. Here is one of them, the kubeadm token list command. It can actually output in YAML, JSON, and human readable formats, as shown here. Unfortunately, the machine readable output effort is a little bit understaffed at the moment, and we're looking forward to have perhaps new contributors to kubeadm who can actually resume that effort and implement machine readable output for practically all kubeadm commands. In addition to that, we already mentioned several times component configs, but what is actually a component config? It's a structured API object that is designed to replace the command line options that are used to specify different settings to Kubernetes standard components. Now, these command line options usually take something like hundreds of different types. So it's good to just put them in a single well-structured object and have that supplied instead of having quite long command lines to different components. So this is why we're trying to actually implement the component config support for components that actually supply such support to them. So we're looking forward into improving the UX here dramatically and have this implemented. With regards to kubeadm standard configuration, currently we have support for V1 Beta 1 and V1 Beta 2, but V1 Beta 1 is deprecated and it's going to be at some point in the near future removed entirely. And at some point in the near future, we are also going to implement V1 Beta 3, which is currently in the process of being discussed. And once that happens, we are going to also deprecate V1 Beta 2 and schedule it for removal at least a year after that. Also, other things that lay ahead for us are the kubeadm operator, which is basically a standard Kubernetes operator that is designed to handle day 2 operations for Kubernetes clusters that were deployed with kubeadm. And this effort is again a little bit understaffed. It was started by Fabrizio Pandini, but currently he doesn't have much time to work on it. So we are looking forward into possibly having some ideas and contributors to that effort too. An additional thing is the integration with the cluster add-ons project. Integrating with cluster add-ons is really nice because it will allow kubeadm to stop maintaining some of the add-ons, and this will make our code base much more narrower and a lot less buggy. Also, trimming the issue backlog is on our agenda. Currently, we have a little bit more than 20 issues in our tracker, but this is not too much, it's not too little, but it needs tackling too. Speaking of the issue tracker, our issue tracker has already been moved to the new Kubeadm repository. You can find it using the QR code on the right. It's basically github.com/community/Kubeadm. If you decide to try to contribute to Kubeadm, there is a really good Kubeadm onboarding video that was recorded by Lubomir last November. A link to that video is accessible through the QR token on the right here, and you can watch it on YouTube. In order to reach us, you have several options. The first option is reaching to us on Slack. We are active in the SIG Cluster Lifecycle channels and the Kubeadm channel. The SIG Cluster Lifecycle channel is a little bit more development-oriented channel, and the Kubeadm channel is a little bit more user-oriented one. Both of these channels are on Kubernetes Slack. Another thing is that we have weekly meetings each Wednesday at 9 a.m. US Pacific time. A link to the Google Doc containing the agenda and the Zoom link can be found on the bottom, but in order to access that document, you first have to join our Google group. That is the Google group for Kubernetes SIG Cluster Lifecycle. A QR code on the right contains the link to that Google group and how to join it. Thanks to these folks here, Kubeadm has been brought to you for the past year and a half to 2 years. Of course, there are many other contributors, ones that came before those and ones that did some simple patches over the past 2 years, but these are the major contributors and the folks that who actually look after and take care of Kubeadm. So thanks to them, you can use Kubeadm right now. And of course, a reminder, SIG Cluster Lifecycle is doing a survey. This survey is a really nice one, and it covers both high-level SIG questions as well as different questions regarding different projects that are under the hat of SIG Cluster Lifecycle. To access that survey, please use the QR code showed here, and remember that when you actually fill in that survey, you actually greatly help different projects and the SIG as a whole. With that, thank you for your time. Questions?
Thank you.